Okay, so now we come to the second part of the video for today's asynchronous lecture. Just now in the first part of the video, we have solved example 6a, yeah? We have solved example 6a. Okay, now for example 6b, I'm not going to solve it here because the step will be the same as how we have solved for 6a. So I will leave it to you as part of our classwork submission today. Okay, so saya nak you all try to solve 6b. Okay, and then submit to through Google Classroom like last week. I will open up the submission in your Google Classroom. Okay, submission due as usual 11:59 tonight. Alright, so this is the first classwork submission for today's asynchronous lecture. Okay, to make sure that you get the correct answer, saya bagi teruslah jawapan. Okay, so just make sure that you are able to get the correct answer. Okay, alright. So if you look here, this matrix is 3 times 3 matrix. Okay, macam tadi yang ni we have 3 lambda kan, 0, 1 and 3. Okay, so by right for this one also you should expect we should have 3 values. Okay, however for this one you got to be careful, you hanya akan dapat 2 value of lambda, negative 1 and 2. But sebenarnya dia ada 3 because this one negative 1 ni repeat twice. So you akan dapat 2 kali negative 1. Maksudnya kalau you solve tu jawapan dia lambda negative 1 square, lambda plus 1 square and then lambda minus 2, something like this, equals to 0. So meaning that lambda eigenvalues of negative 1 occurred twice. So for each of this negative 1 you have to find its corresponding eigenvector. Okay, negative 1 yang first, lambda 1 equals to negative 1, and then eigenvector for lambda 2 equals to negative 1 juga. And then you have to make sure these two eigenvectors are linearly independent. Saya dah explain tadi kan dalam first part of the video macam mana maksud dia linearly independent. Maknanya dia tak depend. Macam sebelum ni kita kata kita assign x tu, kita kata 1 1 1, then kita kata kita boleh juga buat dia 2 2 2. Maknanya yang ni you tak boleh nak assign yang ni adalah for lambda equals to 1, yang ni for the first lambda equals to negative 1, yang ni for the second lambda equals to 1. No, because if you put this way, maknanya ni contoh je, maknanya it will be like it depends. Okay, it become dependent. Maknanya yang dua ni sebenarnya adalah 2 kali this vector. Betul? Okay, it become dependent. Okay, so give yourself a try. Dia sepatutnya boleh. Okay, because jawapan dia definitely not like this lah. Alright, definitely it can be you can choose the eigenvector so that the eigenvector for the first lambda equals to negative 1 will not depend on the eigenvector for the lambda equals to negative 1 yang kedua. Yang ni of course lah will be different lah for lambda equals to 2. Okay, so this is the answer for the eigenvalues. So make sure you find the correct eigenvector for each of the lambda and buktikan they are independent to each other. How to determine? The determinant of yang ni kan, yang you akan cari the eigenvector for lambda equals to negative 1, for first negative 1, second negative 1, and then for lambda equals to 2, and then you put it in terms of eigenvector. Okay, it become an array of matrices, then you find its determinant, show that it does not equals to 0. So I'm expecting a solution from all of you, and kita akan verify your solution in our next Google Meet class. Alright, okay, then I'm going to proceed with the second learning outcome that we're going to discuss for today. Okay, where I want you to to know about types of matrices. We have symmetric matrices, skew symmetry, and orthogonal matrices. Okay, somehow orthogonal ni sebenarnya sama je dengan apa yang kita just discuss tadi, which is linearly independent. Okay, so we'll begin first with symmetric. Okay, apa maksud symmetric? Okay, ni dia tunjuk dah kat sini. AKJ is equals to AJK. Okay, symmetric matrix, a real square matrix AJK is called symmetric if its transpose leave it unchanged. Okay, semua orang dah tahu apa ni, saya sure semua orang faham apa maksud A transpose. Okay, so maknanya kalau dia symmetric, the original matrix is the same as its transpose. Okay, A transpose is equals to A. Later kita akan tengok example lah. Okay, so meaning that kalau kita tukar row jadi kolom, kolom jadi row, it's still the same. Okay, so that is so called as symmetry, ataupun you boleh kata dia ibarat cermin. Okay, value yang kat sini sama dengan value dekat sini. Alright. And then skew symmetric. Okay, this is another one which is call it as skew symmetric if the transposition give the negative of A. A transpose is equals to negative of A. Nanti kita akan check. Okay, A transpose macam tadi, A transpose is equals to A, so that is so called symmetric. But if A transpose is equals to negative of A, then it will be skew symmetric. And then another one is orthogonal. Okay, orthogonal if transposition give the inverse of A. A transpose is equals to inverse of A. Alright, you boleh google lah apa maksud orthogonal kat sini. Kalau dari segi signals, okay, saya kait dengan signal pula dah. Okay, kalau dari segi signal sebenarnya orthogonal ni dia macam ni. Okay, kalau signal macam ni, kita tahulah sinusoidal signal kan. Kalau orthogonal, there are two signals when we call it it's orthogonal to each other. Maksudnya kalau yang ni masa yang ni maksimum, tiba-tiba saya ajar signal and system, tak apa, nak suruh you all faham. Okay, maksudnya kalau masa yang ni maksimum, yang ni akan jadi kosong. Okay, the second signal will be 0. To show this like this. Macam mana tak siap saya lah. If it is orthogonal, maknanya there's the second signal, maknanya bila yang ni dekat, dia lari pula dah. Okay, maknanya kalau dia orthogonal, the second signal, okay, sekarang saya draw yang biru. Okay, yang ni minimum, okay, yang ni akan jadi dekat peak. Dia akan peak, yang ni akan jadi kosong. Lepas tu dia akan yang ni akan jadi kosong, lepas tu dia naik balik macam tu. Macam tu ke? Macam tu lah. Macam tu. Okay, bila yang ni maksimum, dia akan turun. Lepas tu yang ni naik. Lepas tu dia akan naik macam tu. Okay, so maknanya dia akan bertentangan. Alright, sometimes it's not important for you pun sebenarnya, tapi nak suruh you familiar with the word orthogonal tu. It's not only exist dekat matrices pun, matrices it can be vector. Okay, also in signals, also statistic, kita biasa akan dengar later on the word orthogonal ni. Alright, so if for these matrices orthogonal if transposition give the inverse of A. Okay, maknanya kalau you berjaya buktikan A transpose is equals to the inverse of A, then meaning that the matrix A is orthogonal. Alright. Okay, so now this example 7, let's try to identify and validate each matrix here. Either is symmetric. Kalau symmetric macam mana? Kalau symmetric, sekiranya A transpose itu equals to A, right? If it is skew symmetric, maknanya A transpose is equals to minus A. Orthogonal, maknanya A transpose is equals to A inverse. Alright, so let's try for the first matrix here. Okay, ini saya buat sebagai first, yang ni second, yang ni third. Alright. Okay, for the first matrix, okay, macam mana kita nak check? Sebenarnya kalau you tengok, you dah boleh nampak lah sebenarnya. This matrix, tak payah nak buktikan pun, you boleh nampak. Okay, look, the diagonal part ni ibarat sebagai cermin, right? Ibarat sebagai cermin. Kan tadi cakap kalau is symmetric matrix, AIJ sama dengan AJI. You transpose pun dia akan dapat yang sama. So you see here 1 1 5 5. Okay, 5 dengan 5 ni. Negatif 2 dengan negatif 2. Is actually the first matrix is a symmetric matrix. Kalau you tak percaya, you try transposekan this matrix. Dapat tak? A transpose for this matrix, of course, kalau you transposekan, the first row here will be A transpose for A here will be negative 3, 1, 5. The first row jadi first column, negative 3, 1, 5. The second row akan jadi second column, 1, 0, negative 2. And then the third the third row akan jadi the third column, 5, negative 2, 4. So all in all, it come back the same as matrix A. So betul lah. So matrix A here is A transpose equals to A is a symmetric matrix. Okay, matrix A here is a symmetric matrix. Okay, maknanya yang ni adalah symmetric matrix. Okay, what about B? Kalau you cuba transposekan dia, okay, B transpose for this matrix, you akan dapat apa? 0, negatif 9, 12. Okay, saya tukar jadi first column, jadi first row. 9, 0, negatif 20 akan jadi your second row. Okay, and the third column here akan jadi your third row. Negative 12, 20, 0. Will it be equals to B? Sama tak dengan B? Kalau tengok B ni kosong. Betul. 9 dia jadi negatif 9. Negatif 12 dia jadi 12. 9 dia jadi negatif 9. Kosong tak ada maksud, tak ada kesan lah, sebab there's no sign. 20 jadi minus 20. Negatif 12 jadi 12. 20 here jadi negative 20. So the value is the same. It's just that the sign is opposite. So maknanya B transpose is equals to negative B. So from the definition, B transpose is equals to negative B. It is skew symmetric, kan? Kalau kita tengok ni, the diagonal part dia masih lagi sama, cumanya is opposite sign. Okay, kalau 20, negatif 20, negatif 12, 20, negatif 9, 9. Okay, the opposite sign. So matrix B is a skew matrix. Okay, what about matrix C? Okay, nak check ni, kita boleh try lah. Kita boleh try cari its transpose and see how does it relate with matrix C. Okay, so yang ni 2/3, negatif 2/3, 1/3. Saya jadikan first row. And then 1/3, 2/3, 2/3. Saya jadikan the second row. And the third row here 2/3, 1/3, negatif 2/3. Okay, ada nampak tak? Sama tak? Sama tak dengan C? 2/3, negatif 2/3 dah lain dah ni. 1/3, 2/3 dah lain. Okay, so it seems that it's not symmetry, it's not skew symmetry. So most probably it can be orthogonal. How to buktikan it's orthogonal? Maknanya you have to buktikan C transpose is equals to C inverse. So maknanya untuk buktikan this matrix is an orthogonal matrix, you have to find its inverse, which is C inverse. Find C inverse and buktikan dia sama dengan C transpose. Boleh tak? Okay, so today saya nak bagi another one kerja kat sini. Try to find the inverse of matrix C. Yang ni sekejap je sebenarnya. You can do it because it's just like a revision to all of you. Find the C inverse of matrix C and buktikan dia sama dengan C transpose ni. So that you verified that matrix C is an orthogonal matrix. Okay class? Okay, so this is considered second classwork submission for today's asynchronous class. Alright. Okay, so that's all for the second part of the video. We'll see you in the next part, the third part of the video, soon, which is going to be the last part of the video, right? Okay, bye. Bukan bye lagi tau. There will be the last part of the video. Saya tersilap sebut bye tadi.